fine. I'm back. It's the disjoint union set. I didn't jump into that. I don't want to say it's not important, but like for me, I was like, "Ugh, it's a bit tedious." But reading the code, it's easy to understand what exactly is going on, right? Because I hope it is. But we have constructed this class called subset. Let me just raise this up a little bit. So we have defined this class called subset, right? So now this method then unites the two disjointed sets. So with this class up here, we create an array that stores the type, and the type is of subset, right? So it's of our object that we've constructed, which holds the parent and the rank in the constructor. So integer x and integer y, as we go back to the reference variables, these are just like placeholders or pointers that show, okay, this is what you're currently working with. And in this case, this would be our parent and this would be our rank, right? Yeah. And then, so we just check here the conditions. It's like, if the subset of root y, the rank of root y is less than that of rank x, or the rank of root x, then we swap the the values. Like we take root x and place it into root y, and then vice versa. And then I'm just gonna skip. I feel so bad for skipping ahead. Sorry. But anyway, now we are at the method that states we are returning an integer. This is our return type, and the method is called findRoot. And yet again, we construct an array of type subset and integer I, which is then our placeholder, right? So our first condition then tests if this value in the subset dot parent is equal to 1. Return that value, because what we're returning here is the I, and the I is the pointer to that position in the array, because arrays are primitive data structures. They are linear, so it's going to go with each value in the subset. It's going to print that parent variable that we wanted, and then all we do here is assign the find root. So we're taking the subset and subset one dot parent, and then we're assigning it to this new value. So every time this value updates, we are then passing that value to this variable here. We are like we passing this into this, and then we return the subset dot parent. And then finally, this is where we get to the fun stuff, right? This is where we get to what we want to do. Ooh, looking a bit crusty on this. Ooh, never mind. Sorry. Let me lock in. But yeah, looking at the method is finally where we get to instantiate. Ooh, no, it's a bit messy. Sorry.
It was at this moment that he knew.
A few moments later.
Well, it turns out that I cut the video at a specific point in time. Let me just grab a drink quick. But anyway, we are picking back up from our instantiation of the Kruskal's method that takes in integer vertices and a list containing the edges that are within our minimum spanning tree. So when we jump in, it's like integer j is equal to 0 and our edges are set to 0. And then we construct the subset, right? This is our minimum spanning tree. Quotations, quotations, keep that in mind. And then we pass in the vertices into our subset. And then once we do that, we take our edges and then we assign this vertices here into its parameters. That's what we're storing in this array of edges. And then we iterate saying that we're creating vertex subsets with single elements. So integer I, this is just normal iteration, right? I don't wanna yeah, but I would be comfortable with that. So our condition for Kruskal's algorithm begins here where we say that while the number of edges are still greater than vertices minus one, because keep in mind that we don't want a loop, right? We don't want a cycle to form. So we just making sure that we have edges minus one or vertices minus one, which then states we are missing that entire connection to each of the vertices. So now going back to our edges, right? Keep in mind that with each edge that we store its weight, we store its source and its destination. So we say while number of edges is less than vertices minus one, we take the next edge and then we get the value of that edge, right? And then we say integer x is equal to find root, where our subset then takes in the parameter of subset or all the values or all the vertices that are stored in the subset, and then next edge dot source. And then we do the same for integer y. So this finds the source and the destination for our edges, right? Which are then stored in our subset. And then we print out the result of the edges. So results number of edges is equal to next edge. So whatever the next edge is, we then assign it into our array of edges, and then we join together. Because keep in mind that we're using the disjoint sets, so we're bringing two sets together and putting them into position. Then we increment the number of edges, and then we increment the pointer to this value of j. And what the value of j, it keeps on pointing to the next edge within our sorted data structure, because we had to sort the edges first. Excuse me. And then we just print out the variables that we were required to have. And yeah, that's pretty much it. Sorry man, that was quite a bit from my end, but I hope you stuck by. I hope you enjoyed. I'm just gonna have to piece this all together. And I told someone today, I'm like, I don't enjoy editing my videos because I'm lazy and it's a bad habit. I'm not a lazy person, but for this, it's kind of like still feeling it out. I prefer just speaking, having a conversation, and really understanding, not just with me, but with you, because I feel like I'm engaging in a sense. So, yeah, that brings me to that, right? And then binary search trees. I think this needs its own series, bruh. It's cool. It's not even complicated, actually. It's so not complicated, but this is pretty cool if you ask me. But I guess that's me, man. Same time, same place. Don't forget to like, comment, share, subscribe. It's your boy Bad Wiki. And until next time. Oh yeah, I wanted to show you this. So let's hold off until that next time. I'm just gonna jump right in back into this program, right? So I guess with this, I will just share the code, everybody. But this is the means in which we actually understand the functionality of graphs and edges, because for me, it was a matter of working with it, not just in a school context, but like, what can I do with this? And then I just made a little side project. I will explain a bit of the code, right? So this is just to add the edges as we had seen in our notes over here, right? We just have to go back to the graphs and take note of how we add edges to our adjacency matrix. Just simple as this, right? With our pointer variables. No, I should stop doing that. Here. Sorry. But then we jump right back in and then add random edges. So this was the process where I started doing interesting things. I was like, nah, let me actually do something interesting. So I realized like the process of initializing the matrix is very redundant. It's boring. I won't even lie to you. It's very boring. So what I then did was just create a method that adds random edges. So we look at the parameters, it just takes in the adjacency matrix and the number of edges that we want to then place into our adjacency matrix, right? So I then define this random object. I instantiate an object called random, right? From the class called random. And then I set a variable of vertices an integer variable of vertices, and then I make it the size of our adjacency matrix, right? So whatever length or the entirety of the adjacency matrix. And then this is the process of iterating through each of the number of edges that I want to randomly generate. So I just do normal iteration for I is equal to 1, and then I should be less than number of edges I plus plus. And then this is where the magic happens, kinda. And then I take or I create a variable called vertex1, and then to actually get the random values from this class that we have up here, you just have to use the dot next int method, which is kind of similar to using the scanner in the sense you just have to call the next data type in a sense. There's a lot of instances of that. Primarily when you're using the scanner or the result set, you would say next data type practically. That's a good way of painting the portrait, I feel. And then I just do that for both vertices because consider that we are working with a two-dimensional data structure, so I need both for the columns and the rows. And then I check here, my condition is while vertex 1 is equal to vertex 2, and this is a bit of error handling because we can't have a grid with like one square missing. It's gonna be weird. Or the adjacency matrix itself is equal to 1. So everything is in harmony, everything is balancing out, everything equals to 1. And then I just add the random vertices to the adjacency list. No? Am I wrong? I feel like I'm wrong. I feel like this part is a bit redundant. I'll then fix that in post production, I guess. But anyway, yeah, man, that covers pretty much it. And then I did a little bada bing, bada boom, constructed a GUI. And for me, GUIs are pretty self explanatory if you know what you're doing. Because here I just have my panels, my graph container, which then is my two-dimensional array, and my input panel with the button and the JText area. Nah, the J label. Yeah, the J label and the combo box. And then from that point on, I construct additional things that I would need, like that same random number generator, which is over here. And then I construct my GUI as per normal. And then I just had a functionality. Rather than populating it with numbers, I would have rather had it use colors, right? So this is these two for loops over here. Since we're working with a two-dimensional array, we have to iterate through the rows and the columns, right? So I have two instances of iteration. The only thing that really changes is that I say I dot length. So it's pointing to that value of I dot length. And if I'm not mistaken, that's pointing to the row, right? So the entirety of the row. And then adjacency matrix is the entire thing. So, if adjacency matrix is equal to 1, so making sure again that everything is in harmony, take the value of the cells and set the background color to cyan, which is like a blue, if I'm not mistaken. And then this highlights the paths according to the condition of the Dijkstra's algorithm, which unfortunately I didn't cover, but we'll definitely do next time. And then bada bing bada boom programming magic, and then we get this. Alright, and then we just run the algorithm. It looks so cool, dude. I would even lie to you, bruh. And then you just find the shortest path between the 2 points that it randomly chooses. And ladies and gentlemen, that's my time. Thank you once again. This is an honor, it's a blessing. Hope you guys enjoy. And yeah, don't forget to like, comment, subscribe, and share, bro. You know what's up. Bye.